we basically want to go for algorithmic point of view. What is computer science? First of all, you as a computer science graduates, you need to solve certain problems. Why I have taken the computer science is like this Hedgehog type or certain, there is no such irregular shape. Because most of the problem is like this. Most of the problem cannot give you a solution. As a computer scientist, you will be given problem. Facebook, Google, throw you the problem. Even the problem statement, they do not explicit everything. So it is the job of a computer scientist to get the actual statement. Whenever you ask again and again the Google boss or who is the manager, what you want and all this, then the actual thing may come out. That is the definition of problem. And that you call, that is not algorithm again. That is, you try to understand what is the problem definition and all these things. Then you approve it, then you have to selection for which kind of solution. Remember, not any time the programming language choice or the which hardware, it will not come again. First thing you have to select which kind of, first of all you have to find it whether there is algorithm or not. You, like we have shown in jigsaw puzzle, there are lots of problems are there. In fact, most of the 99.9% problem was there no algorithm. That is another interesting topic of our computer science. Faculties and students alike, you have to find a solution of a problem. Like, see, most of the case, whether it's a prime number or not. Say, whether this number, say I have to give any big number, 1, 2, 3, 4, 5, 6, 7, 9. Okay, whether this is a prime number or not. How to prove it? Whether it's a prime number or not? Any idea how to prove it? What is the algorithm? What? Huh? Factors. How? How? You know it should be, first thing is you test it whether it is a odd or even. If it's odd, it's a probability is the prime number. Then you have to divide it in which number. Forget about 1 and 2 because then you should start it whether it is divisible by 3. You should start with divisible of 3. Then what number you should try? Definitely you should try with 5 because if it is 5, it will last is 5 or 0. So you should try it with the 7 in the middle. Yes. So how much will you try? How long will you try? You try to factor. This is, I am taking a problem is whether the number is given, whether that number is prime number or not. What is the algorithm? We should try for how long? We should try till the square root. The smartest way you might answer from to go to the last row. If we do not find the after the square root, then we can declare a number is prime. There is lots of this also comes very early. It is not very. But this is the algorithm. You can go. This is a much better algorithm. If you go to the till n minus 1 or n minus 2. So this is the algorithm. First of all, whether you can find the algorithm or not. Then what kind of algorithm it is? First of all, we have chosen the first algorithm is, what is the algorithm? What's the name of this algorithm? Brute force. What is brute force algorithm? Brute force algorithm, like whatever you have done, your bubble sort, or selection sort, or insertion sort, these are basically no intelligence at all. These are basically brute force algorithm. You try to compare everything with everything, and you will get, except the complexity, you will get OS. Much better algorithm is March sort. You get the complexity O n log n, huge advantage. Whenever it's log n, whenever the number of terms goes to million, the log million is much less than 10 steps. 2 to the power 10 is 1k, 2 to the power 20 is 1 million. So it's much lesser steps. So that is a log n advantage you get. That is a divide and conquer. So that is a divide and conquer is a interesting algorithm. March sort. Lots of intelligence. Okay. Any idea? So this is common example is your March sort is an example of March sort. There's a lot of things. Anything else? What is the next step? What is the next algorithm? What is randomized? Randomized algorithm means you can start the problem at different random points. If they come to a same point, then you can declare this a solution. And quicksort is one of the randomized algorithms. There are lots of people are working on randomized algorithm. It's much quicker way, but you cannot problem. So you have to visualize, that is the job of a computer scientist. You have to know lots of algorithm techniques, and you have to search for various techniques. Definitely brute force is a different algorithm, but it is maybe the slowest algorithm. March sort is different. Then quicksort, randomized algorithm is quicksort. Whenever you choose a cohort, the randomized order, it gives much better result than March sort in most of the cases. Quicksort worst state is O n square, but most of the cases is n log n. It's much better. I'll give benefit. Then what is the next step? What's the next algorithm? Dynamic program. Dynamic program. We could calculate, say, factorial 7. What is to be done? Factorial 7. Then in factorial 7 is nothing but 7 into 6 factorial. Then it will is equal to 7 into 6 into 5 factorial. Okay? Then this way you can go. Now again you are given factorial 8. What is to be done? Again 8 into factorial 7. 8 into factorial 7. So I have to redo the everything again. So generally this complexity is comes whenever this you are going again and again, the complexity goes to exponential time. Generally the complexity is 2 to the power n. It's exponential algorithm. You are every time you do. But this algorithm, if we save the factorial 7 algorithm in some array, then we just use it. I have saved factorial 7 in array and factorial 8 I just use it. Whenever I get the factorial 9, I will just 9 into factorial 8. I save it. In our programming, we are not saving it as every time we go for scratches. So you have to take the factorial 8, you go for factorial n minus 1, n minus 2, n minus 3. But in every step, you save the value in an array and use this, then it will be much easier. And if complexity comes much less than 2 to the power. So that is called dynamic process. You divide, but you also save the result for later use. Okay, there are lots of things there. Then another algorithm, anything, what is the fixed step? Biologically inspired algorithm. What is biological? There are 2 steps. One is genetic algorithm, like this algorithm inspired from our mutation, how we are born, how the father-mother genes are mixed values, why we generally, in most of the cases, it is not recommended the marriage should not be there within the close cousin. What is the reason? It may accentuate the diseases. So if we have to survive, you have to go for different survivors so that any disease should not go in between. So you basically our XX genes, XY genes, our parents, whenever we are born, they are mixed. So that there is not chance. See, we have a color blindness in both cases. So take the case of hemophilia. And it is always recommended that you should, before marrying, you should check whether you are carrying hemophilia or not. You may be dormant carrier. If both the husband and wife is the hemophilia carrier, the 75% chance is there the son or daughter should. So these are called genetic algorithm, biologically inspired algorithm. We say for survival of the program to get better result, we can allow the mutation and all these things. So how they are and the fitness function, whether we can survive or not. This is a big complex thing, but lots of problems can be solved by the genetic programming, genetic algorithm. Are you getting a little bit of it? So you allow mutations of the problem, or mutation of the problem statement, and try to solve this. For all problems, you cannot solve it. Like sorting problem, you cannot do genetic algorithm. But there's some problem space is there. You can use the genetic engineering or genetic programming. It is called biologically inspired algorithm. Any doubt? So it is kinds of a. Then another. What's the next step? What's the next algorithm? Artificial neural networking. Do you know what is neuron? Any idea of neurons?
Yes, sir. Yeah, messenger.
Yes, messenger. Basically, neurons are nothing like it. Like this is a neuron, and this is a kind of neuron. I am drawing it. It is single cell. Remember single cell. Then it is a. This is a single neuron. This is called particular portion in the body. You can call it a soma. And these are the inputs. I want everybody should look at board. Don't look at the screen. You are not doing any brain thing. You should ask the question. Please, I am talking to you. Don't look at the board. You have to make a small program and you come. Okay? So please, ask me a question. So what is this? What is this diagram? Neuron. A single cell neuron. How many neurons, number of neurons expected in our brain? Huh? What is? Millions. Billions? No. 10 to the power 35. We have 10 to the power 35 neurons to our brain. A huge number. And this is a, and these are the dendrites, and these called the axon. This is the output, and this goes to another dendrites. So whatever response is coming, and the response can come up to 10 to the power 4. So one neuron can have an input of 10,000 to synapse, and the result, whether it crosses 1, whether it goes to 1 or 0, only binary, and it will give the result to few. So we have a 10 to the power 35 neurons in our brain, and every neuron can have 10 to the power 4 input. So that way we compute. We generally compute that way. So that's the computational power. If you want to make the factorize something, say if you want to make say 12 into 13, what is this? 6, 13 and 12, 6, 5. So if you want to give a factorize a number, our human brain, 156, it is difficult, it will take time, maybe maybe 50 seconds to get the actual the 12 into 30. But if you are giving a picture of Sachin Tendulkar or Virat Kohli or any other, you can quickly follow it. So our human brain is very good at vision, audio processing. But even our latest computer cannot quickly figure it out. Sachin Tendulkar various ways. So our 10 to the power 35 neurons is better for speech processing, vision processing, much good, but we cannot factorize the big number. But for a computer, this is a nanosecond. Definitely 2 milliseconds. Big number, you give a big number, computer can do it, your slowest laptop can do it within a second. But the computer cannot do whatever we can do. So human intelligence is different. Computer intelligence, whatever you have done is different. So certain cases we have to solve the problem by biologically inspired algorithm. That is called artificial neural network technique. You can also program, but generally this programming is done not by C, by Python. So that is the reason. Whatever I am saying, this thing, these are the still can be done by C. But from the artificial neural network technique, it is generally preferred technique is the language is the Python. Okay? There is some ant colony optimization and all these different algorithms. So first of all, you have to choose which kind of algorithm you should choose. If you want to go vision processing or image processing, you may go for artificial neural network technique, or this is the technique. For sorting algorithm, you can go for brute force, or you can go for divide and conquer, like Marx. After you selection the algorithm, then you have to write the program. Then you can select which language I should write the program. why you go for C? If you go for C if you want to be faster. C is still the best. But if you want your program should be used by all over the world, you write a program that can be used all over. So maybe C may not be the best choice. Maybe the Python, maybe Java, which can be the best choice. And which kind of data structure you put your data? What is data structure like? You can put your data in array, you can put your data in single linked list. Linked list means an array with a pointer. So it can go next to next. So or double linked list, you can traverse this also. Not only you can forward, you can reverse. That is called double linked list. You can put your data in a tree, say binary tree. Say you can put your data in binary search tree. We just give an example. Just give an example here. Please tell me some random number from 1 to 30, 1 to 90, 99. Please quickly tell. Say 10,
31.
7, 33, 81, 87, 30,
1.
5, okay, 9, 64, 59. So I want to put this data in the binary search. What is binary search tree? Let's try what is binary search tree. So binary search tree, you know how many of you in the binary search tree? Let's try. So first in binary search tree, I have to find whether there is a duplication of number. No such duplication. So it can be done in binary search. Remember, binary search tree cannot take duplicate values. Okay. So what is the first element? 10. So I put the 10 element as a root. Then comes 07. Where should I put 07? Very good. Right. Then comes 33. Where should I put? Very good. 81. Where? Huh? No.
Under 33 right side.
No, but 81, but how? How? You are correct. Somebody who says it should be the right side of 81. Correct. But
33.
how? What is the algorithm? The algorithm is you have to take the number 81 to always come to the root. Always. And see 81 is greater than 10. Then you come to 33. Then you say 81 is greater than 33 and nobody is there. Then you can put 81. So that is the algorithm and you avoid this part. So that is the divider counter, we get the advantage of log A. Again I will come. Put 81, then 87. Where should I start?
Side of 81.
Oh, you have to again go to 10. Again go to 10. Okay? Then 35. Where to go? Again 10, 33, 81.
Left of 81.
Are you getting? Because 35 is less than 81 plus greater than 33. Any confusion? Then comes 09. Again start from 10. Okay? Then comes 64. 59. Get it? Now, what's the good thing about it? If you take the projection, you take the projection. What is the projection? 7, 9, 10. If you take all the projection, you say it is a sorted. This is sorted. Automatically sorted. Are you getting the point? So whenever you make a binary search tree, Solve. Okay, so this is a binary. So what is the problem of this? What is the problem? See, you are not getting the much advantage because this side is. See another problem. Let's go this. So we have a random data comes like this. We have a problem data 10, 12, 13, 14, then 9. So this data, how to put it in binary search tree? First is 10, 12 is right side, 13 is right side. So if you go this, what is the, if I can put the data in single linked list, then you have to find the data in again ON. I am not getting any advantage of divide and conquer. Divide and conquer, I get the advantage if I can avoid the left tree. It's like in earlier, then you get the log n advantage. If you have to go every state like this, next state is 14. So this is not a better, it's a binary search tree. The finding time is not n log n, not log n, not log n, you will get the n. Because it is a very skewed binary search tree. There is no left hand side. So it is, we are not getting the log n advantage. So there is another way we can make log n advantage. What to do? For whenever you make a tree like 10, we always see what is the length of the left child and what is the length of the right child. What is the length of the left child? No child. So 0. What is the length of the right child? No child. 0 minus 0. Then you put 12 here. What is the length of the left child?
0.
0. Again, left child is 0, right child 0, 0, 0. But what about this? It is 0 and right child is 1. This is 1. So it is a minus 1. Are you getting? I have to, at every node, I put a value, length of the left child minus length of the right child length. And whenever you see is 0 is okay, whenever you see minus 1 is okay, whenever it reaches minus 2, we flip the tree. We'll see whatever happens. Say, now it comes 13. So I put 13. Again here, 13. And 13 here, what is the length? 0, minus 0, 0, 0. And what is the case? 1. Minus 1 is okay. What is? Minus 2. This. So from here, from this side, number of, this is 0, level, and here the depth is 1, 2. So minus 2, it will be minus 2. That is objection. So I am not getting advantage. And minus 2 is not advantage. So I withdraw this. What I do, I make it flip. So I make new root 12, then 30, and then 10. And we recalculate our this thing. This is level 0 minus 0, 0, 1 minus 1, 0, 0 minus 0, 0. When there is a binary search tree, the same logic holds. We just, now it's a new root, and this called, do you know what is this tree is called? Any idea? This is automatically rotated and you are guaranteed you will get advantage of log n. Not n. In all cases. This is called AVL tree. AVL tree. Automatically balanced. You will always get log n. Whenever there is a case of minus 2 comes, it will rotate. Any confusion? So I have covered today till AVL, and now I ask for a question. So why I covered binary search tree today? I covered what is different types of algorithm. What is algorithm? Algorithm must have some definite number of steps, and there should not be any loop. Loop means the algorithm must start and must stop. Algorithm like OS is not an algorithm. OS is continuously looping. Whatever you're running, so that is not algorithm. Algorithm is must start, must stop. Algorithm should depend on data according to the complexity, but the dependency on data should not go to for each and individual data. Like whenever you are a picture, you jigsaw puzzle, you try everything with everything. That is not an algorithm. That is not a process. Not every problem you should find an algorithm. Not every problem is algorithm, so you have to find it. That is the challenge of interesting areas of computer science as a student. So even if algorithm is there, then you try to reduce the complexity. Complexity is two types of complexity mainly there. One is mainly called the time complexity, another is space complexity. Time is how much time it requires, space is how much extra memory it takes, and there is another complexity called energy complexity, how much energy it takes, and then another complexity is amortized complexity. We'll cover it later, maybe in your next year classes. But now we have to understand time complexity. The time complexity should not depend on the programming language. You should not go to the C programming to find the complexity. Complexity, you should try to write algorithms, try to find the calculator for complexity. It should be done by a machine. So it should independent of machine, independent of programming language. In whichever your better algorithm program will run faster on any slowest computer, even you hire a mainframe, your slowest computer will win if your algorithm is better. So that is the plus point. That means if you have the best computer, doesn't mean you can solve all the problems. So algorithm is always has a much better factor. Algorithm must be written in a language, plain English language. Algorithm should have input, algorithm should have output, and algorithm definitely the input should be present in a maybe array, maybe tree, maybe linked list, and this is mainly algorithm. Then what type of different algorithms are there? One algorithm is definitely brute force, that you try to solve the problem and do it like our insertion sort, like our bubble sort. And generally brute force algorithms are possible. It takes time consuming, but it requires, so it is not that you can get rid of it. For small number of cases, brute force is okay. Then the next best algorithm is divide and conquer. You divide by half or divide by half, you solve it and merge it. That is the best example is the merge sort. You should go for it. So merge sort is give the advantage of n log n. Whenever you go for log n, it matters. Whenever n is close to the 10 to the 6 billion, then you will get the advantage. Like 2 to the power 10 is 1024. So typical algorithm is in double sort it will take say 1000 into 1000, and if you go for the merge sort 1000 into 10 n log n. What is n of 2 to the power 10? 10. So that is a huge advantage of n log n. How the log n comes? Log n comes in any algorithm you find that any division is going there, division by 2, then the log n comes. One best example, you go for the binary search tree combination. When a binary search tree, you must take a node value. Anything higher, go to the right, anything lower, the left. The problem of binary search tree is the tree, it depends on which way the number comes, the tree becomes too much skewed on left side or right side. If it's too much skewed on left side or right side, that is called unbalanced tree. Unbalanced tree, you just not guaranteed you can get the point by log n advantage. Actually, why you put your data in binary search tree? In a sorted way, so that you should get the advantage of log n, not n. Then if you have n, then you can put the data in array. You go each and element, find the element. But if you put in the data in tree, I know If it is greater, I should move to the right branch. If it is lesser, I go to the left branch. So I can decide maybe maximum half of the number in the beginning. So that is the reason I get the log in. So that is, if it can be guaranteed, if we just improvise the binary search tree, what if we add an extra field in the node? Whenever you put the data, we always, every node should have a length of the left subtree and length of the right subtree. And if it is within 0 and 1, it is okay. It is bit unbalanced, but not totally unbalanced. If it is the balance factor goes -2 or +2, we flip the tree. Either right flip or right. That is called the AVL tree. You get the advantage of logging. Okay. So that is the called AVL tree and this thing. Then that is the divide and conquer. Then the randomized algorithm is you can start the processing at random, and that will give some quicker advantage. Randomized algorithm will always give better most of the cases. Example is quick sort. We go through it. Then comes the dynamic programming. What is dynamic programming? You intermediate result, you save it and reuse that result. It is also given like a divide and conquer, but you get the result or you reuse it. Then biologically inspired algorithm, like genetic algorithm, like how our evolution comes. It depends on the problem where the genetic image processing, computer vision, maybe genetic algorithm is good. Okay. Then the artificial neural network technique, because we think our humans, we have a 10 to the power 31 neurons, and every neuron has 10 to the power 4 connections into it, and every neuron only one output, and it is basically output is 0 or 1, and it motivates or triggers the next neural level. We think that way. So we cannot do the multiplication quickly, but we can do image processing, video processing, signal processing very quickly. How? So definitely this neuron structure definitely can do better than even the today's modern. So modern computer algorithm technique try to mimic our human thinking system. So there are technical algorithms which is suited for this kind of problem. That is the idea. Then after you selection an algorithm, you try to decide which programming language. Right now, with the C is kind of assembly language programming. It is, if you require C, if you understand C very well, then you can understand other programming language very well. C is like a kind of a Sanskrit of modern language. If you learn Sanskrit, you can learn Bengali, Hindi, even Tamil, Telugu, even German, because Sanskrit is basic language, so much rich in syntax. So it is always preferred. You cannot bypass C. Go for C. But if you learn C very well, like one problem is whenever we learn driving, we started driving an Ambassador car. Then we start right now I'm driving Maruti car. So if I can learn Ambassador well, I can drive any car in the world. So that's the so toughest. So same way, the C is the toughest. If you learn C, that will help you to learn other language. You cannot bypass C. Okay, C has lot of faults, but you have to learn it. But that is the mother language and host language. And there are better language. But sometimes if you make bad result in C, that should not hurt. The C is really difficult language to learn. Even whenever I come to even ourselves or whenever we come to lectures, so we also see books and then come. It is not that if you cannot do, it doesn't mean you don't know. So you have to go repeat again and again. And I always recommend you go for international books, not for any local author books, because our local author books is high reprinted, maybe it is 1 or times or 2 times. But what about the 150 world countries and last 10 years? You should go this kind of books like Cunningham Ritchie, Robert Redford, Herbert Shield. These books are everywhere in this world, all over the world. Stanford, MITs, IITs. So you should read those books. Please don't read any local authors, even for all computer science subjects, because we hardly Indians have any contribution to computer science. Some people say we have some Arjavaddu and all this. But I don't believe it. Currently, computer science field, we have zero contribution. Maybe Infosys and they can a little bit of better programming under direction. So you have to follow the leaders. The leaders are always from European countries and American countries, and they are the doing. And it's a young subject. It is not like physics. We can boast of physics like Shotel Bose, Meghnad Shah. But in computer science, we have no one person, not a single person. So it is better to follow who have done it. Dennis Ritchie, who has developed Unix in C. You should read his book. So that is one point. And you should read also, you should listen also MIT and Stanford video lectures. Not even NPTEL videos. You always, the MIT, Stanford video lectures are very good. You should read it. Any questions? But you should listen my video lecture because I will ask the question. That's it. Okay. Please see my videos. Some of people are giving the down arrow. What is it? Down? What is the reason? Yeah. No, I don't get it. I can count everything. Everything is tracked. Who is giving? I know. Okay. Achha, any question? Any question? No, I ask the question. If somebody else, you have asked the question. No, you can ask. Any questions on C level? Any questions? Yes, everyone should ask the question. Yes? Time complexity of binary search, I have told once, it is log n. Log n. Log n, log n, log n. Not n log n. N log n is merge sort. Heap sort. It is log n. Because you are divide at the root, you always try to see, you have to find at the root and left or right, everywhere you are given divide and conquer. Whenever you divide and conquer, it is log n and base is 2. Any other question? Good question. Please ask any question on any C programming or anything. Question? You should have question. If you don't have a question, that means you have not understood. Until and unless you should have some 1,000 questions. Yes? You can ask second question. No, if others cannot ask. You? Yes. Ask question.
Sir, whom do we give preference to? Time complexity or storage complexity?
Time complexity?
Or storage complexity?
Yes, it's a good question. I have already answered. His question is, which complexity should matter most? Whether it is a time complexity or whether it is a space complexity. Yes, but not always. Not always. If you have a very small mobile phone and if you have a very few number of memory, maybe space complexity. Maybe you have a pacemaker and at your, I don't want your any relative, maybe mine, if somebody has a pacemaker. Now in pacemaker, time complexity should not matter, not even space, maybe energy complexity. So that it should the least amount of energy, so that I have to change the battery once in a year, not in once in a 2 months. So time complexity not always prefer. But most of the cases, time complexity we prefer. 99% case. Maybe some cases if the two algorithms have the same time complexity, then you go for the which one gives the space complexity. Okay? Have I answered your question? Good question. Time complexity, space complexity. Then another complexity is called amortized complexity. Amortized is full lifetime and life cycle of the program. What is the average complexity? Are you getting my point? Time complexity says 1 instance, 7 instance. And it always comes in worst case. Worst case is at the difficult time. And sometimes we call the average. Sometimes we check the average also. Like quick sort, the time complexity is better than merge sort. 99 cases, quick sort is better than merge sort. But in certain cases, maybe less than 1%, quick sort time complexity is O(n) square, same as merge sort. Same as selection. But it is theoretically can be shown that quick sort is better than merge sort, most of the cases. But is worst case is O(n) square, so the best case is, average case is O(n) log n. And n log n is better than merge sort n log n. So sometimes we consider also not only worst case, we consider also the average case. And another case I have mentioned, that is called the amortized time complexity. Amortized means not only first best case and average case, whole life cycle. If you take, then take the average, that is called amortized complexity. It's a difficult concept. We'll go for the timing, the time complexity. Any more question? But why am I? Yes, go your question.
As we have already specified.
Be louder so that you
As we have already specified, so algorithms are independent of whatever programming language
Yes.
they use.
Again and
So
again.
which language is good, which language bad, this depends on the features they provide. Now,
Not
C-
always, yes, you carry on, I'll ask.
Now C is not machine independent. C has so many problems. That's
Yes.
why C++ was created to improve the problem.
But the same problem is C++ and C are same. C++ you can object-oriented programming.
Object-oriented programming,
And-
polymorphism.
Yes, that is also machine dependent.
Yes. But Java is machine independent and Python
Ma'am.
is used wide,
Yes.
widespread usage of
Yes.
Python is there. So why do we sometimes consider C as one of the best languages?
Because C, every language comes from C, because and every language interpreter or compiler are written in C.
C. Exactly.
C is C language program after its executable condition like a.out, it is machine dependent, but the source code in 99.9 recurring% in machine independent. Are you getting my point? Whenever the .c file almost is machine independent. That is the beauty of C. So whatever new computers is coming out, it will definitely have a C compiler. Why? Because if you have to run Java or Python, you have to run a virtual machine. What is virtual machine? It is independent of a machine you have to run. And what language you should write it? C. So C you cannot escape. So every hardware whichever is coming, definitely has a C compiler should be with it. I don't know any other computer where the C is not there. So C you must learn, because anything you run, it's a Java or Python or Ruby, whatever the language is, it directly not run on hardware. On a direct hardware, we create a virtual machine, and that virtual machine is same for mainframe to your mobile phone, we run on it. To write that program, you need C. So that is the reason C is a definite a language you should compare. C is 10 times faster, minimum. C is 10 times faster than Java. Sometimes performance required all operating system utilities are written in C. Have I answered your question? Yes.
Sir, as you said, most of the compilers and interpreters of languages have been written using C.
Yes.
Sir, can any compiler or interpreter of any programming language be written without C?
Yeah, it is theoretically possible. I am not saying impossible, but till practice is 99% written in C. But it is possible. Any other interpreter can be, yes, it is possible. It is theoretically not impossible. Any other question?
Sir,
Yes.
sir, by looking on what factor,
Can you be louder, please?
by looking on what factor can we say that a language is slower, other language is faster?
By running the program. By writing a sample program, which is better. But C is always 10 times faster. And not only that, how you write the program, which algorithm you are choosing, that is also determines your speediness. Are you getting my point? Not only language, which algorithm. Like if you choose a bad algorithm, like bubble sort, it is n square. But better algorithm is selection sort. Though it is n square, the selection sort is better algorithm. If you choose a merge sort, much better. So not only language, your algorithm choice, how you put your data in. If you put your data in a binary search tree, it will be slower. If you put your data in AVL tree, it will be faster. So how you put your data? Actually, computer program is garbage in and garbage out. You put the data in a array or binary search tree or AVL tree. The AVL tree is better to get the data. Your program acts on data. So data should be in an intelligent structure. Okay? Any more question? Good question. Any question? Don't have question. You should have every day you should have question. This it will be whatever I answered the question, this will be asked to And that is a good advantage. If you ask the question and get it answer, the same question. Okay? Thank you very much for listening, and please see this video. Thank you. We basically want to go for algorithmic point of view. What is computer science? First of all, you as a computer science graduates, you need to solve certain problems. Why I have taken the computer science is like this Hedgehog type or certain. There is no such irregular shape. Because most of the problem is like this. Most of the problem cannot give you a solution. As a computer scientist, you will be given problem. Facebook, Google, throw you the problem. Even the problem statement, they do not explicit everything. So it is the job of a computer scientist to get the actual statement. Whenever you ask again and again the Google boss or who is the manager, what you want and all this, then the actual thing may come out. That is the definition of problem. And that you call, that is not algorithm again. That is, you try to understand what is the problem definition and all these things. Then you approve it, then you have to selection for which kind of solution. Remember, not any time the programming language choice or the which hardware, it will not come again. First thing you have to select which kind of, first of all you have to find it whether there is algorithm or not. You, like we have shown in jigsaw puzzle, there are lots of problems are there. In fact, most of the 99.9% problem are there, no algorithm. That is another interesting topic of our computer science. Faculties and students alike, you have to find a solution of a problem. Like, see, most of the case, whether it's a prime number or not. Say, whether this number, say I have to give any big number, 1, 2, 3, 4, 5, 6, 7, 9. Okay, whether this is a prime number or not. What's the, how to prove it? Whether it's a prime number or not? Any idea how to prove it? What is the algorithm? Huh? Factors. How? How? You know it should be, first thing is you test it whether it is a odd or even. If it's odd, it's a probable case of prime number. Then you have to divide it into which number? Forget about 1 and 2 because then you should start it whether it is divisible by 3. You should start with divisible of 3. Then what number you should try? Definitely you should try with 5 because if it is 5, it will last is 5 or 0. So you should try it with the 7 in the mid case. So how much will you try? How long will you try? You try to factor. This is, I am taking a problem is whether the number is given, whether that number is prime number or not. What is the algorithm? We should try for how long? We should try till the square root of it. The smartest way you might answer from to go to the last row. If we do not find the after the square root, then we can declare a number is prime. There is lots of this also comes very early. It is not very. But this is the algorithm. You can go. This is a much better algorithm. If you go to the till n minus 1 or n minus 2. So this is the algorithm. First of all, whether you can find the algorithm or not. Then what kind of algorithm it is? First of all, we have chosen the first algorithm is, what is the algorithm? What's the name of this algorithm? Brute force. What is brute force algorithm? Brute force algorithm, like whatever you have done, your bubble sort, or selection sort, or insertion sort, these are basically no intelligence at all. These are basically brute force algorithm. You try to compare everything with everything, and you will get, check the complexity, you will get OS. Much better algorithm is March sort. You get the complexity O n log n, huge advantage. Whenever it's log n, whenever the number of terms goes to million, the log million is much less than 10 steps. 2 to the power 10 is 1k, 2 to the power 20 is 1 million. So it's much lesser steps. So that is a log n advantage you get. That is a divide and conquer. So that is a divide and conquer is a interesting algorithm. March sort. Lots of intelligence. Okay? Any idea? So this is common example is your March sort is an example of March sort. There's a lot of things. Anything else? What is the next step? What is the next algorithm? What is randomized? Randomized algorithm means you can start the problem at different random points. If they come to the same point, we have to go, we have to search for various techniques. Definitely brute force is an acceptable algorithm, but it is maybe the slowest algorithm. Marsh sort is preferred. Then quick sort, randomized algorithm is quick sort. Whenever you choose a cohort, the randomized order, it gives much better result than Marsh sort in most of the cases. Quick sort worst case is O n square, but most of the cases is n log n. It's much better. I'll give them. Then what is the next step? What's the next algorithm? Dynamic program. Dynamic program. We could calculate, say, factorial 7. What is to be done? Factorial 7. Then in factorial 7 is nothing but 7 into 6 factorial. Then it will is equal to 7 into 6 into 5 factorial. Okay? Then this way you can go. Now again you are given factorial 8. What is to be done? Again 8 into factorial 7. 8 into factorial 7. So I have to redo the everything again. So generally this complexity is comes whenever this you are going again and again, the complexity goes to exponential time. Generally the complexity is 2 to the power n. It's exponential algorithm. You are every time you do. But this algorithm, if we save the factorial 7 algorithm in some array, then we just use it. I have saved factorial 7 in array and factorial 8 I just use it. Whenever I get the factorial 9, I will just 9 into factorial 8. I save it. In our program, we are not saving it as every time we go for scratches. So you have to take the factorial 8, you go for factorial n minus 1, n minus 2, n minus 3. But in the every step, you save the value in an array and reuse this, then it will be much easier. And if complexity comes much less than 2 to the power. So that is called dynamic process. You divide, but you also save the result for later use. Okay, there are lots of things there. Then another algorithm, anything, what is the fixed step? Biologically inspired algorithm. What is biological? There are 2 steps. One is genetic algorithm, like our is algorithm inspired from our mutation, how we are born, how the father-mother genes, the mixed values, why we generally in most of the cases it is not recommended the marriage should not be there within the close cousin. What is the reason? It may accentuate the diseases. So if we have to survive, we have to go for different survivors so that any disease should not go in between. So you basically our XX genes, XY genes, our parents, whenever we are born, they are mixed. So that there is not chance, say we have a color blindness in both cases. So take the case of hemophilia. And it is always recommended that you should, before marrying, you should check whether you have a carrying hemophilia or not. You may be dormant carrier. If both the husband and wife is the hemophilia carrier, the 75% chance is there the son or daughter should. So these are called genetic algorithm, biologically inspired algorithm. We say for survival of the program to get better result, we can allow the mutation and all these things. So how they are and the fitness function, whether we can survive or not. This is a big complex thing, but lots of problems can be solved by the genetic programming, genetic algorithm. Are you getting a little bit of it? So you allow mutations of the problem, or mutation of the problem statement, and try to solve this. For all problems, you cannot solve it. Like sorting problem, you cannot do genetic algorithm. But there's some problem space is there. You can use the genetic engineering or genetic programming. It is called biologically inspired algorithm. Any doubt? So it is kinds of then another, what is the next step? sequential neural networking. Do you know what is neuron? Any idea of neurons?
Yes, sir. Yeah, messenger.
Yes, messenger. Basically, neurons are nothing like it. Like this is a neuron, and this is a kind of neuron. I am drawing it is a single cell. Remember single cell. Then it is a this is a single neuron. This is called particular portion in the body. You can call it a soma. And these are the inputs. I want everybody should look at board. Don't look at the screen. You are not doing any great thing. You should ask the question. Please, I am talking to you. Don't look at the board. You have to make a small program and you come. Okay? So please, ask me a question. So what is this? What is this diagram? Neuron. A single cell neuron. How many neurons, number of neurons expected in our brain? Huh? What is? Millions. Billions? No. 10 to the power 35. We have 10 to the power 35 neurons to our brain. Huge number. And this is a, and these are the dendrites, and these called the axon. This is output, and this goes to another dendrites. So whatever response is coming, and the response can come up to 10 to the power 4. So one neuron can have an input of 10,000 to synapse, and the result, whether it crosses 1, whether it goes to 1 or 0, only binary, and it will give the result to few. So we have a 10 to the power 35 neurons in our brain, and every neuron can have 10 to the power 4 input. So that way we compute. We generally compute that way. So that's the computational power. If you want to make the factorize something, say if you want to make say 12 into 13, what is this? 6, 13 and 12, 6, 5. So if you want to give a factorize a number, our human brain, 156, it is difficult, it will take time, maybe maybe 50 seconds to get the actual the 12 into 30. But if you are giving a picture of Sachin Tendulkar or Virat Kohli or any other, you can quickly follow it. So our human brain is very good at vision, audio processing, but even our latest computer cannot quickly figure it out. Sachin Tendulkar various ways. So our 10 to the power 35 neurons is better for speech processing, vision processing, much good, but we cannot factorize the big number. But for a computer, this is a nanosecond. Definitely 2 milliseconds. Big number, you give a big number, computer can do it, your slowest laptop can do it within a second. But the computer cannot do whatever we can do. So human intelligence is different. Computer intelligence, whatever you have done is different. So certain cases we have to solve the problem by biologically inspired algorithm. That is called artificial neural network technique. You can also program, but generally this programming is done not by C, by Python. So that is the reason. Whatever I am saying, this thing, these are the still can be done by C. But from the artificial neural network technique, it is generally preferred technique is the language is the Python. Okay? There is some ant colony optimization and all these different algorithms. So first of all, you have to choose which kind of algorithm you should choose. If you want to go vision processing or image processing, you may go for artificial neural network technique, or this is the technique. For sorting algorithm, you can go for brute force, or you can go for divide and conquer, like Mark's. After you selection the algorithm, then you have to write the program. Then you can select which language I should write the program. Why you go for C? If you go for C if you want to be faster. C is still the best. But if you want your program should be used by all over the world. You write a program that can be used all over. Maybe C may not be the best choice. Maybe the Python, maybe Java, which can be the best choice. And which kind of data structure you put your data? What is data structure like? You can put your data in array, you can put your data in single linked list. Linked list means an array with a pointer. So it can go next to next. So, or double linked list, you can traverse this also. Not only you can forward, you can reverse. That's called double linked list. You can put your data in a tree, say binary tree. Say you can put your data in binary search tree. We just give an example. Just give an example here. Please tell me some random number from 1 to 30, 1 to 90, 99. Please quickly tell. Say 10,
31.
7, 33, 81, 87, 30, 5, okay, 9, 64, 59. So I want to put this data in the binary search. What is binary search tree? Let's try what is binary search tree. So from binary search tree, you know how many of you in the binary search tree? Let's try. So first in binary search tree, I have to find whether there is a duplication of number. No such duplication. So it can be done in binary search. Remember, binary search tree cannot take duplicate values. So what is the first element? 10. So I put the 10 element as a root. Then comes 07. Where should I put 07? Very good. Right. Then comes 33. Where should I put? Very good. 81. Where? Huh? No.
Under 33 right side.
No, but 81, but how? How? You are correct. Somebody who says it should be the right side of 81. Correct. But
33.
how? What is the algorithm? The algorithm is you have to take the number 81 to always come to the root. Always. And see 81 is greater than 10. Then you come to 33. Then you say 81 is greater than 33 and nobody is there. Then you can put 81. So that is the algorithm and we avoid this part. So that is the divide and conquer, we get the advantage of log A. Again I will come. Put 81, then 87. Where should I start?
Side of 81.
Oh, we have to again go to 10. Again go to 10. Okay? Then the 35. Where to go? Again 10, 33, 81,
Left of 81.
Are you getting? Because 35 is less than 81, thus greater than 33. Any confusion? Then comes 09. Again start from 10. Okay? Then comes 64. 59. Get it? Now, what's the good thing about it? If you take the projection, you take the projection. What is the projection? 7, 9, 10. If you take all the projection, you say it is a sorted. This is sorted. Automatically sorted. Are you getting the point? So whenever you make a binary search tree, it is automatically sorted. If you look at the bottom side, if you take a vertical projection, then it will automatically see it is a sorted. you are not getting the much advantage because this side is, see another problem. Let's go this. So we have a random data comes like this. We have a problem data 10, 12, 13, 14, then 9. So this data, how to put it in binary search tree? First is 10, 12 is right side, 13 is right side. So if you go this, what is the, if I can put the data in single linked list, then you have to find the data in again ON. I am not getting any advantage of divide and conquer. Divide and conquer, I get the advantage if I can avoid the left tree. It's like in earlier, then you get the log n advantage. If you have to go every state like this, next state is 14. So this is not a better, it's a binary search tree. The finding time is not n log n, not log n, not log n, you will get the n. Because it is a very skewed binary search tree. There is no left hand side. So it is, we are not getting the log n advantage. So there is another way we can make log n advantage. What to do? For whenever you make a tree like 10, we always see what is the length of the left child and what is the length of the right child. What is the length of the left child? No child. So 0. What is the length of the right child? No child. 0 minus 0. Then you put 12 here. What is the length of the left child?
0.
0. Again, left child is 0, right child 0, 0, 0. But what about this? It is 0 and right child is 1. This is 1. So it is a minus 1. Are you getting? I have to, at every node, I put a value, length of the left child minus length of the right child length. And whenever you see this is 0 is okay, whenever you see minus 1 is okay, whenever it reaches minus 2, we flip the tree. We will see whatever happens. Say, now it comes 13. So I put 13. Again here, 13. And 13 here, what is the length? 0, minus 0, 0, 0. And what is the case? 1. Minus 1 is okay. What is? Minus 2. This. So from here, from this side, number of, this is 0, level, and here the depth is 1, 2. So minus 2, it will be minus 2. That is objection. So I am not getting advantage. And minus 2 is not advantage. So I withdraw this. What I do, I make it flip. So I make new root 12, then 30, and then 10. And we recalculate our this thing. This is level 0 minus 0, 0, 1 minus 1, 0, 0 minus 0, 0. When there is a binary search tree, the same logic holds. We just, now it's a new root, and this called, what is, do you know what is this tree is called? Any idea? This is automatically rotated and you are guaranteed you will get advantage of log n, not n, in all cases. This is called AVL tree. AVL tree. Automatically balanced. You will always get log n. Whenever there is a case of minus 2 comes, it will rotate. Any confusion? Okay. So I have covered today till AVL, and now I ask for a question. So why I covered binary search tree today? I covered different types of algorithm. What is algorithm? Algorithm must have some definite number of steps, and there should not be any loop. Loop means the algorithm must start and must stop. Algorithm like OS is not an algorithm. OS is continuously looping. Whatever you're running, so that is not algorithm. Algorithm is must start, must stop. Algorithm should depend on data according to the complexity, but the dependency on data should not go to for each and individual data. Like whenever you are a picture, you jigsaw puzzle, you try everything with everything. That is not an algorithm. That is not a process. Not every problem you should find an algorithm. Not every problem is algorithm, so you have to find it. That is the challenge of interesting areas of computer science as a student. So even if algorithm is there, then you try to reduce the complexity. Complexity is two types of complexity mainly there. One is mainly called the time complexity, another is space complexity. Time is how much time it requires, space is how much extra memory it takes, and there is another complexity called energy complexity, how much energy it takes, and then another complexity is amortized complexity. We'll cover it later, maybe in your next year classes. But now we have to understand time complexity. The time complexity should not depend on the programming language. You should not go to the C programming to find the complexity. Complexity, you should try to write algorithms, try to find the calculator for complexity. It should be done